Afternoon YouTube, I'm Chucky2009 and today we're going to be doing something that's very new, at least here in the US, and very exciting, at least to me. So this is pulse stick welding. As anyone who has even the most vague familiarity with pulse TIG or pulse MIG can guess, it's basically stick welding, but instead of what we think of as stick welding, where you just set the machine to say 120 amps and you just weld at that amperage, give or take an amp or two depending on arc length or something. This is different. This is, well, there's a pulse involved. So just like your pulse welding arc, you know, there's a high point on the pulse and a lower point on the pulse, and you bounce up and down between those two. And the advantage of this is you get many of the advantages of welding at a higher amperage. Let's say if I'm running 1/8 inch 7018, normally I'd run that about 120 amps or so. But if I turn that up to say 150 amps, then I could move a lot faster, I could penetrate more deeply into the material, maybe you get a little bit better fusion. The downside of that is it would not run very well. It would warp the material. There'd be an insanely high amount of heat input, and it would just in general be a mess. I think we can all agree on that. But the great thing is, you know, if I'm only welding at 150 amps for part of the pulse cycle, and then we go down to say, I don't know, 70, 75 amps, and then back up again multiple times a second, I end up with a nice, fairly smooth, very controllable arc, and I basically get many, if not all, the advantages of welding at a higher amperage without many or any of the disadvantages of that as well. So you may be asking yourself, where might I use this? There's a lot of practical applications, as mentioned, in general fabrication, maybe even some pipe welding adventures. That you get many of the advantages of welding at a higher amperage and a higher output. But you know, it can really come into its own when you go to weld thinner material, because you know, if you need 90 amps to weld this thin piece of material, perhaps with a gap in it, but you're at 90 amps constantly, then you might end up warping it or burning through. But you know, having the pulse cycle bring the current back down, then back up, then back down again can lower the overall heat input and keep the puddle in place and make it nice and controllable for you as well. If there's a gap in something, pretty much the same thing. It lets the puddle cool a little bit so you don't just burn through. And it's not really known here in the US. I'm not aware of any machines on the market here in North America that will do this, with the exception of the Invertig 221 from our channel sponsor HTP. Normally it's a high-end AC/DC TIG machine. Also has a very nice high-end stick welding mode, which obviously we'll be using today. So very, very brief history of pulse stick welding. If this tickles anybody's pickle, I'll put some links in the video description below. You can read up on your own. But basically it was invented around 2005 by an Italian company, and around 2012 or so it started to take hold in Europe. Now there's a German manufacturer that builds a pulse stick welding function onto many of their higher end machines, and now, even though it's pretty much completely unknown here in the US, over in Europe there's code work that specifies it. So you know, maybe somewhere there's a bridge welding code or a boiler welding code or a pipe welding code, for instance, that says you need to use this electrode pulse stick welding with this many hertz at this power output, for instance. So I think that's kind of cool. So if you're watching this video, you very well might be one of the first people in North America to know about this, because like I said, it's pretty much unknown here. Regardless, let's set up the machine. I think you'll be pleasantly surprised at how easy this is and how nice it is to run. I had honestly never done this before today. I came out here and practiced for a couple hours, and now I'm ready to show the basics of this to you guys. Alright, so I'll reach around back and fire up this machine. And just like that, the mighty Invertig roars to life. So this is really easy to set up because the Italian company that more or less pioneered pulse stick welding decided that a 50% pulse time on and a 50% background current are pretty much ideal for virtually any pulse stick welding application. Therefore, most of the work is already done for you because this high quality HTP Invertig comes with those two settings preset from the factory. So you know what this means is we've all seen our pulse curve kind of shaped like that. What we see here on the dial is the peak current. So we're going to have a peak current of 140 amps as such, and the background current, the low end of the pulse, is going to be half of that, which in this case is 70 amps, and then a 50% pulse time on as well. Now, pretty much all you adjust with this is the amperage. Technically it's the peak amperage, but we'll just refer to it as the amperage since we don't really adjust the background current. And we can also adjust the frequency, and to do that all we do is we press this little pulse knob, and then just like that we can turn this way down to 0.4 hertz, and it goes pretty friggin' far up here as well, all the way up to 5 hertz, which for this is extremely fast. Now From my own testing and that of my buddy Pete, who also makes welding videos on YouTube and has spent quite a bit more time doing pulse stick welding than I have, he recommends generally staying between 2 and 3 hertz. And so we're going to turn this down. I find it's largely just personal preference, you know, running 6010, 6011. I like a lower frequency with the 7018 I've run. I find usually 2.5 or 3 hertz gives the best results, but you know, as you can see, we got a lot of adjustability there. And with that being said, let's get started and see what this feels like. So here's something I thought was very interesting. Although we have the machine set to 160 amps as its peak current, its average current, you know, when that 160 amps is averaged out against its background current, which is, you know, half of that, we end up with approximately 120 amps of welding current, which is, as most of you guys know, about where I'd normally want to run an 1/8 inch 7018 like this. See, it all averages out. Now I want to weld a little bit with some 3/32 inch 7018s, and normally, I don't know about you guys, but normally when I run 3/32 7018, I run it at about 90 amps, and when I run 1/8 inch, I generally run it about 120 or so. And I found out really just through my own little short bit of experience here that the 1/8 inch 7018s doing the pulse stick welding function with them works really well at 150 to 160 amps or so, and the 3/32 variety seem to run really nicely around 120 amps. So I'm sure it's purely coincidence. It probably doesn't translate to other electrodes, but the 30 amp difference that I usually use going between regular stick welding with 3/32 and 1/8 inch seems to somewhat carry over to this. But again, I wouldn't take that as a rule of thumb because it's probably different for other things. But regardless, I'm just going to set this to 120 amps, and pulse wise, I'm actually going to speed this up a little bit to 3 hertz, just personal preference. But as we found, like I said earlier, generally anywhere between 2 and 3 works out really well, but I personally prefer 3 hertz with the smaller electrodes. Alright, so coming from that thin sheet metal, now what I want to do is run some 6010 and some 6011 with this machine. And one thing I'll note is that most inverters generally struggle with those two, especially the 6010. And this one, from my limited experience running it earlier, it actually runs the stuff extremely well, even without the pulse function. So with the pulse function, I think I want to run this at approximately 120 amps. Now, as most of you guys can probably guess, anyone who's ever done the whip and pause, you can assume we probably want to slow this down a little bit, and that'd be correct. I find that generally these two electrodes run best between 1 and 2 hertz, but again, that's largely personal preference. However, I'm going to run it at, we'll start out here at 1 hertz and maybe turn it up a little. So the main difference in running 6010 and 6011 in pulse stick welding as opposed to just traditional old stick welding is that normally in the latter you have to do some type of motion. A lot of folks like the whip and pause, some care for the circular E-type motion. But regardless, with pulse stick welding, all you do is a simple, slow, straight, steady drag motion, and the pulse of the arc will naturally work to form that nice stack of dimes look that we all try to achieve. And it's quite a bit easier and somewhat faster. Alright YouTube, so that was a lot better than I thought it would be, to be brutally honest. You know, I've had people ask me in the past, like, why is it your stick welding? Why is it your pulse stick welding? How come you never see this? Would this work? And I'm like, why would anyone ever want to do that? You know, why bother? That sounds really stupid. But my mind is made up. This is actually quite impressive today. So, coming out here this morning, I had zero pulse stick welding experience. And pretty much instantly I was able to use the settings that I got from my buddy Pete, and I just got the machine set up really quickly, and I was in business. And those are the same settings that I later relayed to you guys. It just plain works. It works really well. It's very easy. That's the thing. It's certainly not harder than regular stick welding, and to be honest, in a lot of ways, it's easier than regular stick welding. For instance, with 6010, 6011. No longer do you have to do any sort of motion. You just set this thing to, what did I say, like 1.5 hertz, and just do a straight drag. And you get some really easy little dimes there, some really pretty little dimes there. And same thing with the 7018. I know that normally doesn't require any real sort of emotion, maybe if anything, just a little side-to-side action to flatten out the puddle. But even that, you know, it looks a lot better, it's a lot smoother. Somehow there's less spatter. I'm not really sure how that works, but it does. And I like it. The other thing, vertical welding, that's the other area where this really, really shines. You know, to be honest, I have never put down better looking vertical stick welds with less effort than I have running pulse stick. It's really easy. You know, normally when you go to weld vertically, especially vertical up, you're mainly working against the force of gravity pulling that puddle back down. But the thing is, at the bottom of each pulse cycle, the puddle partially freezes. Say that 10 times fast. So ultimately you're working against a lot less than you would be vertical stick welding without that. You guys saw in that one clip, I just stuck the 7018 in there and just ran straight up, no technique, no motion, no skill, and got a pretty decent looking weld out of that. And I like it. I think this is going to become a staple here in my shop. I'm honestly just incredibly impressed with the process. And this machine also, I don't have much time running a 221, but this thing seems very, very easy to learn. And there's really just not much to it. You set the amps and you set the frequency and you're in business. So yeah, really, really excited about this. Someone came to me a couple years ago and was like, this is going to revolutionize stick welding and this is going to be everywhere in 10 years. I probably wouldn't have believed them, but I honestly think it will be. And you guys saw at least my attempt at it here first. So That was a lot of fun. I certainly learned something. I hope you guys did as well. Put some links in the video description for some homework, if you will, if anybody else wants to learn about this process and some of the research that's gone into it. Yeah, those were my humble first attempts here. Really pleased with it. It was everything I hoped it would be and more. And I think it's going to be in a lot more videos to come. So thanks for watching. Have fun. Stay safe. See you next time.